Hello, fifth grade. This is our lesson for Tuesday, March 31st, and we'll be looking at lesson 13.3. I wrote the little letter A there because this is a longer lesson, so we're going to break it up into 2 days, and similarly, we're going to break up the homework pages between 2 different days. So this first section is going to be looking at pages 195 to 197. To some extent, this is an extension on yesterday's lesson when we started to look at angles on a triangle. But we're going to start to look at some specific kinds of triangles and the relationship that triangles have with their angles for those special kinds. And today we're going to be looking at right triangles. Do you remember what makes a right triangle as opposed to a different kind? If you're looking at this, you may have thought, that's a right triangle right there, and you'd be correct because there's a right angle on it. Remember, triangles always have at least 2 acute angles, and then the other one is either right, as it is in this one, obtuse, or acute. This is a right triangle. And then from last lesson, I know right away what all 3 of these angles added up are. And what are they? If you're thinking 180 degrees, you were thinking correctly. They all add up to be 180 degrees. Is there anything else to know about any of these angles? Well, because this is a square, you know that's 90 degrees, don't you? So actually think about this as a bar model for a second. If the bar model for all 3 angles, let's label this ABC. Angle A, angle B, and angle C added together equal 180 degrees. And angle B makes up what portion of that? Angle B is 90 degrees of the entire thing. So if I made a smaller bar model just out of A and C, what do those 2 combined have to be? Well, together they have to be 90 degrees, don't they? I don't know specifically for this one what's the split. This one looks like it may be a little bit more obtuse than this one, but I'm not sure. But I know that together they have to be 90 degrees. So that A plus C plus B equals 180 degrees. So if I gave you the measure of one of these, I'll just randomly choose, what if this one was 40 degrees? Well then 90 plus 40 plus something has to equal 180. Well, this would be 50. And 50 plus 40, that's 90 degrees. So in a right triangle, the other 2 angles add up to be 90 degrees. And that way we'll make sure that a right triangle, all the angles add up to be 180. Let's look at how we can use this in some example problems. This is on page 196. You can look at this right triangle. I know it's right because that's a square. Otherwise I couldn't assume that. And this is 60 degrees. And let's label this one DEF. Because this is a right triangle, that's going to be 90 degrees, I know that E plus F have to be equal to 90 degrees. And I know that E is 60 degrees plus whatever F is to get 90. Subtract 60 from both sides, and F has to be 30 degrees. That makes sense, it's an acute angle, and all 3 of those added up. If I added 90 to 30 and 60, I get 180. So again, another example of acute angles in a right triangle adding up to be 90 to eventually get you to 180. That's essentially all this lesson is. Let's look at the practice problems, though, on page 197 to make sure that we truly understand that. Here's a right triangle. This is 73 degrees, and notice in your book it says not drawn to scale, so I can't bust out my protractor and measure this out. I've got to do the math behind it. But thankfully, the math isn't too complicated. I know that 73 plus something has to be 90. So the angle of M is equal to 90 degrees minus 73 degrees. 90 minus 73, angle M is equal to 17 degrees. Ooh, that's pretty small. Is my angle pretty thin? It's quite thin, so that seems to check out. Check out this next one. Angle T plus 45 degrees would have to equal 90, because then this plus your right angle would get you to 180. Subtract 45 degrees from both sides. I'm left with T equaling, well, sides actually also equal to 45 degrees. And those do look pretty similar sized, even though it's not drawn to scale. That would make some sense. Now this one's going to make you think a little bit more, but I'm sure we're up for the challenge. This one, they've given me this angle up here, and they haven't given me anything else. And the two that they're asking for is this one right here and this one over here. And I know that this angle right here, I'll go over it again with my green pen to make it clear, is a right angle. And so is this one up in this corner. Let's see, how can I do this one? Well, the largest triangle is a right triangle, isn't it? I've got my right angle here, an angle up here, and an angle down here. And I know what that angle is. So this angle plus this angle that I've labeled as y have to equal 90 degrees because it's a right triangle. Which means that y is equal to 90 degrees minus 74 degrees, which means y has to be 16 degrees. That's a pretty thin angle. That makes some sense. All right, how else can I figure out this one? Ooh, well, this is a right triangle too, isn't it? If I cover up this small one up here, I can see that this is 16 degrees. That's a right angle. So x plus 16 has to equal 90. That's kind of the problem I just did, isn't it? Let's do it out though. X is equal to 90 degrees minus 16 degrees, which means x has to be equal to 74 degrees. And actually, if I look a little bit more and see that this is a right angle too, 74 plus this angle would have to be, this is 16 degrees. And 16 plus 74 would make that a right angle. So it really seems to work in multiple ways. It can feel a little bit confusing pulling out the numbers this much, but I hope that actually clears it up for you. And you can see this has to be 16 degrees because of the big triangle. And because of this kind of middle-sized triangle, this has to be 74 degrees, so that'll add up to be 90. All right, your homework today, let me get the exact page numbers. It's just one page front and back, 125 to 126. Tomorrow you'll have a little bit of a larger homework assignment as you finish up this section, but this is a nice warm-up. So go ahead and start those pages, check your work, and then watch my video on it. And then tomorrow we'll look at a couple different types of triangles. Thank you.